So this screencast is about electronegativity, and electronegativity really has to do with how badly an element wants an electron to fill up its outermost shell. And you can see fluorine at the top right-hand side has an electronegativity of 4.0 because it has 7 valence electrons and would really like one more to fill its outermost shell. While in comparison, you have francium at the bottom left-hand corner with a electronegativity of 0.8, and that only has 1 valence electron, which it would rather get rid of, forming a +1 charge instead of gaining 7. So let's go on to the worksheet and each section. For section 1, it says, in each pair of bonds, put a star next to the more polar bond and use an arrow to show the direction of polarity in each bond. So what you need to do is look up your electronegativities for carbon and oxygen. So carbon is 2.5 and oxygen is 3.5, and the difference between those two is 1.0. And then you would look up carbon, again 2.5, and nitrogen 3.0, and the difference is 0.5. So which one is more polar? Well, the one with the greater electronegativity difference is more polar, so it's going to be CO. And the next thing was to show an arrow to indicate the direction of polarity. So we're going to point it towards the side that's more electronegative. So in this case, we're going to point the arrow to the right here and to the right here. Okay, so that's what you're doing for that section. Let's try another one, PBr and PCl. So PBr, so P is 2.1. and Br is 2.8, P is 2.1, and chlorine is 3.0. There's a difference of 0.9 and 0.7. This one is more polar, and both of these arrows will end up pointing to the right-handed element there, okay, or right-sided element. So that's what you're doing in section 1. In section 2, it's just the arrow, which atom is more negatively charged or which has a higher electronegativity. So carbon is 1.0, nitrogen is 3.0, it's going to point to the right, and you're going to do that for each one of those. All you're doing is looking at the difference in electronegativities. Okay, the bottom part here is another important section that's on your exam, and it has to do with taking the differences of the electronegativities, looking at the chart, and then determining what kind of bond is occurring based on electronegativity difference. So let's do 2 of those. Let's do Na and Cl. Na is 1.0, Cl is 3.0. The difference is 2.0. According to our chart, if it's greater than 1.7, it's ionic. If you go back to our chart, anything in between 1.7 and 0.5 is polar covalent, and anything lower than 0.5 is nonpolar or pure covalent. Okay, let's look at C and H. C is 1.0 and H is 2.1. The difference is 0.9. If I look and see where that is in relationship to the chart here, this is going to be polar covalent. And that's all you do with that section. Hopefully that helps you figure out how to determine the type of bond depending on electronegativity differences, and how to figure out which bond is more polar based on the electronegativity from the chart. So again, electronegativity has to do with how much an electron, or I'm sorry, how much an atom or element would like to gain an electron to be a stable element. All right, I think that's it, and let me know if you have any questions.